So I'm going to have a go at the next Codility exercise in lesson 6, sorting, and the exercise is called max product of 3. So let's get straight into it. Okay, a non-empty array A consisting of n integers is given. The product of a triplet PQR equates to A at index P multiplied by A in index Q multiplied by A at index R, and P is greater than or 0 to 0, Q is greater than P, R is greater than Q, and the length of the array is greater than R. For example, array A such that the array is like this. It contains the following triplets: 0, 1, 2. Product is, so A at 0 is -3, A at 1 is 1, and A at 2 is 2. So -3 times 1 is times 2 is -3 times 2 -6. The next example, PQR, is 1, 2, 4, which is 1 times 2 times 5 is 10. 2, 4, 5 is 2 times 5 times 6 is 60. Your goal is to find the maximal product of any triplet. Write a function that, given a non-empty array A, returns the value of the maximal product of any triplet. For example, given that example, the function should return 60, as 60 2 times 5 times 6 is the maximal. Write an efficient algorithm for the following assumptions. N is an integer within the range of 3 to 100,000, and each element in the array is an integer within the range of -1,000 to 1,000. Okay, so I guess we're not going to want to scan through the whole array and multiply every 3 combinations, because that will be many loops. I think that the complication in this one is that a negative times a negative is a positive, because what I'm thinking is we just need to find the 3 largest numbers in the array, and once we've got the 3 largest numbers, just multiply them together. But of course, something like -3 times -2 would be a positive 6. Now if we multiply that by a negative again, we'll have a negative. So what I think we've got to do is find the 3 largest numbers in the array and the 2 smallest numbers in the array, and then return the maximum product out of the 2 smallest numbers multiplied by the largest number and the 3 largest numbers. I think that's right. Okay, so what I'm going to do is scan through the array, and I want to remember the 2 smallest and the 3 largest numbers. And then once I've got those values, I will try the 2 different combinations of multiplying the 3 largest and the 2 smallest and the largest. Of course, if the smallest aren't negative, this doesn't matter, but I think I'll just do it anyway. So I'm going to make an int array smallest, an int array of 2 length, and I'm going to initialize both of these values to be integer max value. I'm going to make another array of the largest, and I'm going to initialize those to integer min value. So integer min value, every integer value is higher than that except integer min value, and integer max value, every integer value is lower than that. So now I'm going to add two methods. They're both going to be similar, and what they're going to do is consider whether the value that we give it should go into this. So this will be in the smallest array. The first value will be the smallest value we've seen so far. The second value will be the next smallest value we've seen so far. So I'm going to write a method, consider small. We're going to give that a value, and I'm going to say if a is smaller than the value at the first position of the smallest array, then the value at the second position of the smallest array will equal what is currently at the bottom position, and the first value in the smallest array will equal a. In other words, if the value that we're sending into this array is smaller than the first position, we move the first position to the second and put the value in the first position, because we're sort of keeping a sorted list here. And if it's not smaller than that, if it's smaller than the next value, so else if a is less than the next value, then we'll just set the next value to be a. So if we run every value through that, this array will end up with the smallest value in position 0 and the next smallest value in position 1. Now I'm going to make another. I'm going to do the same for largest, only this time we've got 3 positions. So I'm going to say consider large if a is greater than largest at position 0, then largest then we're going to move, because we've got 3, I'm going to move what is at position 1 into position 2, what's at position 0 into position 1, and a into position 0. Else if it's smaller than the first value, we're going to move 2 to 1 and set the value at 1 to be a. Else if it's smaller than what's at the second index, we'll just put it into the second index. So now I run every value through through both of these methods, and we end up with the 3 largest numbers and the 2 smallest numbers. But crucially, for efficiency, we're only going to loop through the array once, so we'll have a ON efficiency. So for int a in a, consider large a and consider small a. Right, these are int values, so int product 1 is the largest value multiplied by the next largest value multiplied by the next largest value. So the 3 large values added to get multiplied together. The smallest will be the smallest value, or the largest value multiplied by the 2 smallest values. Now, what if one of them is negative and the next one is positive? It doesn't matter. just going to end up being small. If only one of these values, if an odd number of these values are negative, then we're going to end up with a negative number. And if all of the values in the array are negative, then this product 1, even if it's -1, -2, -3, that's still going to be larger than 3 small negative numbers. So I think that the maximum of these two products is it. So return math.max product 1 and product 2. I think that's it, but I'm going to debug through it just to make sure everything is doing what I want. And I'm just going to check the description again. Each element in the array is an integer within the range of -1000 to 1000, so we don't need to worry about the integer overflowing. An integer can well manage a billion, which is 1000 times 1000 times 1000. And also the length of the array is at least 3. But even if it was less than 3, well, we'd end up using integer max value and we would end up with an incorrect result. But we know that there's at least 3 values in the array, so I think that that's it. I'm just going to run it and see if we get a sensible answer. The answer we're looking for is 60. And we're going to debug through it. I'll just debug at this point and check what's in our array. So smallest is -3, -2, which is what we expect, and largest should be 652. Yeah. So that's 60, and 6 times -3 -2, 36. Okay, I think that's it, and I think I'm going to submit that. It's a little bit more involved than some of the other exercises because I've added these extra 2 methods and the smallest and largest array. So it's more than just the solution method itself. But I think that that's it, and I think that that's going to be efficient. Of course, if every time we put a value, if the values get larger and larger, we are going to have to keep on calling a couple of lines there, but crucially we're not looping within a loop, so I think it's still efficient. Run the tests. It's just tested the one example, and I'll submit the task and see how it does. I'm a little bit nervous, but I think it will get 100%. $16 minutes to do the task. %. Wrong answer. One triple, 3 elements, wrong answer. For the test input 4510, it returned 0. Okay. 4510. 4, 5, 1 are the largest values. So we would expect it to return 20, and I think that's what it said in the description, but it returned 0. Yeah, okay. So let's debug through that. So the largest is 501. I've left these as less than. And they should have been greater than. So I presume now it's going to work. So my logic was sort of correct, but I just made a mistake that didn't trip up the tests. So I'm just going to resubmit that, and hopefully this time 100%. I can't believe I got 45% with quite a massive error, but there you go. Run the tests again and submit. And 100%. Okay, so we had some extreme large, including max int. We had large ranges, large random numbers, yeah, and the time complexity is n times log n. So that's not bad, but I did make a pretty stupid mistake by when I copied the smallest function to the largest one. I forgot to reverse the less than symbol to be the greater than symbol, but there you go, little error there, but ended up with 100% in the end. So thanks for watching.